I am Gina May Pacon.
I'm Novim GB Kaget-Get.
I am Wilmar Vankin Kitoriano.
And welcome to AV Power Engineering 101.
Let us define what a tractor is and its main function. A tractor is a farm vehicle that provides assistance for performing agricultural tasks such as plowing, planting, cultivating, fertilizing, and harvesting crops. A cab is a type of enclosure that is later on added to modern tractors and are also considered a safety cabin for the driver. A muffler is a device on a tractor to which the exhaust gases from the internal combustion engine passes through to reduce the noise of the engine. A muffler can also be considered as a silencer. The engine is the machine with all the functioning parts which converts power into motion.
Final drive. Final drive is a gear reduction unit in the powertrains between the differential and the drive wheels. It transmits the power finally to the rear axle and the wheels. The tractor rear wheels are not directly attached to the half shafts, but the drive is taken through a pair of spur gears. Next, we have the rear wheel. Rear wheel acts as a drive wheel and are usually bigger than the front wheels. It is to avoid the sloping in muddy surfaces. Next is the differential. Differential allows the driving wheels to have different speeds. When spinning, this is important because the outer wheel moves faster than the inner. They would literally burn rubber if they were chained together and forced to travel at the same pace. Transmission box, or also known as the gearbox. A transmission box or gearbox is a mechanism that changes the input drive speed to a lower or higher output speed or reverses the direction of rotation. Tractor gearbox are usually multi-ratio, with the modern ones being of a continuously variable design or also known as the CVT. Front wheel. Front wheel is used for steering and are usually designed to be smaller than the rear wheels to provide a better view for the driver. Ballast. Ballast is a material added to the front of a tractor for the purpose of enhancing traction and stability.
A hood, a hinge cover over the engine of the tractor. Side mirror. Mirrors found on the exterior of the tractor outside the driver's peripheral vision. Steering wheel. Steering wheel is used to turn the steering tire. Chassis. Chassis supports all the parts of the automobile. Roll-over protective structure or ROPS. 2 or 4 post structural frames primarily used to protect the driver from being crushed in case the tractor rolls over. Driver seat. Seat for the driver's or operator's comfort.
Clutch. Clutch is a device used to connect and disconnect the tractor engine from the transmission gears and drive wheels. Clutch transmits power by means of friction between driving members and driving members. Light control lever. Fuel throttle. A throttle body is a butterfly valve located between the air intake filter and the intake manifold. It regulates how much air can go into the engine. Differential brake. Differential brake is a band brake acting on the difference of two motions or tensions and tending to the self-tightening when the rotating parts turn in the normal direction. The differential braking system provides equal braking efforts on all wheels of the tractor. Gear control lever. Gear control lever, a metal rod that used to change gear in a car or other vehicle. A gear stick is the device used to change gear.
Hydraulic control lever. It's a hydraulic system that allows a tractor to raise, hold or lower mounted or semi-mounted equipment. 3-point hitch system. The weight and resistance of an implement is transferred to the tractor's drive wheels. Power takeoff drive is a device that transmits the mechanical power of an engine to another piece of machinery. Single hitch system is the tractor component that connects the primary mover and the implement into a single functioning unit.
What is an engine? An engine is a machine designed to convert one or more forms of energy into mechanical energy. Mechanical heat engines convert heat into work through thermodynamic processes. Engines such as the ones used to run vehicles can run on a variety of different fuels, most commonly gasoline and diesel in the case of cars. And now, let us identify the parts of an engine. First one is the cylinder. A cylinder is a vital part of the engine. It's a chamber where fuel is combusted and power is generated. The cylinder consists of a piston and two valves at the top, which are the inlet and the exhaust valves. The piston moves up and down, and its reciprocating motion generates power that moves your vehicle. Next one is the clearance volume. Clearance volume is used to find the compression ratio. Volumetric efficiency, which affects the efficiency of an engine. If clearance will be less, it will bang the piston. If clearance is more, it will pull off the air during suction stroke, which creates problem in compression. Next is the exhaust valve. Exhaust valve is a valve that releases burn gases from a cylinder. The exhaust valve closes during the initial part of the induction stroke.
Cylinder head. 5 functions of the cylinder head are: it houses the valves, spark plug or fuel injector, and serve as cover for the cylinder block. Dissipate the heat produced by the engine and therefore produce cooling. Contain the passages for coolant, oil, and combustion gases. Act as the combustion chamber seal and the engine's mechanical control powerhouse. And lastly, take the compression resulting from combustion pressure. Cylinder liner. Functions of cylinder liner are the following. The cylinder liner acts as a reciprocating surface for the piston. Helps to transfer heat, provide a better sealing, and withstands combustion. The cylinder liner undergoes wear and tear to protect the cylinder block from damage. Spark plug. A spark plug has 2 major functions in internal combustion engines, which are: first is igniting the fuel or the air mixture. Second, removing of heat. Note that as electrical energy is transmitted through the component, it ignites the gasoline or the air mixture in the combustion chamber. Spark plugs cannot create heat, but they can only be used to remove heat. Inlet valve. The main function of the inlet valve is it allows air or air-fuel mixture to enter the engine cylinder. Combustion chamber. The main function of the combustion chamber includes: it provides a confined space for the combustion of air and fuel mixture. It houses the inlet and outlet valve for an incoming and outgoing mixture. It houses and guides the piston. It helps in proper combustion by proper geometry. It withstands the high temperature of combustion. It prevents spilling the exhaust from the combustion.
Piston is a component of reciprocating engines, reciprocating pumps, gas compressor, hydraulic cylinder, and pneumatic cylinder, among the other similar mechanism. It is the moving component that is contained by a cylinder is made gas tight by piston rings. Piston work by transferring the force output of an expanding gas in the cylinder to a crankshaft, which provide rotational momentum to a flywheel. Such a system is known as reciprocating engine. Piston ring is a metallic split ring that attach to the outer diameter of a piston in an internal combustion engine or steam engine. The main function of the piston ring is sealing the combustion chamber so that there is minimal loss of gases to the crankcase. A piston pin is a pin through the skirt of a piston in an internal combustion engine, to which the little end of the connecting rod is attached. A piston pin transfers the enter power out of the combustion process from the piston via the conrod to the crankshaft, and it's the most stressed part of an engine. Piston cylinder. A cylinder is a vital part of engine. It is a chamber where fuel is combusted and power is generated.
Connecting rod. The portion of a piston engine that connects the piston to the crankshaft is called the connecting rod. The connecting rod in conjunction with the crank converts the piston's reciprocating action into crankshaft rotation. Crankshaft. The crankshaft of a diesel engine converts the piston's linear motion into rotational motion, which is then transmitted to the load. Bed plate. The bed plate is the engine's or construction's base on which other structural components like the A-frame, all columns and guides are mounted, and it can endure high, fluctuating stresses from working parts. Crankcase. The crankcase is the engine's most important component. The complete crank mechanism is housed here, including the pistons, cylinders, and connecting rods.
The camshaft is a mechanical component of a tractor's combustion engine to which it is assigned to operate the poppet valves. It is also a rotating object that converts rotational motion into reciprocal motion. A flywheel stores the combustion momentum to keep the crankshaft from turning in between the engine's power strokes. The oil pan is the reservoir for oil, or the metal dish that holds the engine oil when it is not circulating around the engine itself.
Let us begin with the advantages. So why do we have to choose diesel engine? Number 1, it produces much more torque or the engine's rotational force. It also uses lesser fuel than other known engines. It also produces higher power output and it is long-lasting and durable. Moving on with the basic components of an IC engine, also known as internal combustion engine.
These are the components of an internal combustion engine. This part is the cylinder head cover. We also have the cylinder head cover gasket. Now this is called rubber grommets. This part is called the cylinder head. Here we have the part known as the distributor. Attached to the distributor is the distributor O-ring. Here we have the intake manifold. We also have the intake manifold gasket. This part is called the camshaft pulley. This part right here is known as the head gasket. Now you call this part the oil filter. This part is known as the water pump. Here we have the water pump gasket. This circular object is known as the timing belt drive pulley. We have here the oil pan gasket. This is the oil pan drain bolt. Let us move with the oil pan. This part is known as the drain bolt crush washer. We call this the engine block. Here we have the exhaust manifold gasket. And lastly, the exhaust manifold.
Let us now proceed with the different classifications of engine. So how can you classify engines? Well, you can classify engines according to the following. Number 1, you can classify an engine according to its basic engine design. Is it reciprocating or rotary? Number 2, you can classify an engine according to the fuel it uses. Does it use gas? Does it use alcohol? Does it use petrol? Or does it use diesel? Did you know that you can also classify an engine according to the number of its stroke? It can have a 2-stroke or a 4-stroke. You can also classify an engine according to the fuel ignition method it uses. Does it use spark ignition, compression ignition, or a hotspot ignition? You can also classify an engine according to its working cycle. Does it use an Otto cycle, or does it use an engine cycle, or does it use a dual combustion cycle? Number 6, you can also classify an engine according to the fuel supply and its mixture. Is it a carbureted type or an injection type? Number 7, you can also classify an engine according to the number of cylinder it uses. Does it use a single cylinder or a multi-cylinder? Number 8, you can also classify an engine according to its cooling method. Does it use water-cooled or air-cooled? Did you know that speed is also a classification of engine? Is it a slow speed engine? Is it a medium speed engine? Or is it a high speed engine? You can also classify an engine according to its cylinder arrangement, its valve, and location. You can also classify an engine according to its governing method. Is it hit and miss governed? Is it quantitatively governed? Or is it qualitatively governed? Last but not the least, you can also classify an engine according to its air supply method. Is it through aspiration, through turbocharging, or through supercharging?
Cycle operation complete in 4-stroke in a piston or 2 revolution of a piston. So there are 4 stroke: suction stroke, second, compressed stroke, third, expansion stroke, and lastly, the exhaust stroke. First, the suction stroke. In this part, the suction valve is open and the exhaust valve is closed. Suction stroke is a charge consisting of a fresh air mixed with the fuel is drawn into the cylinder due to the vacuum pressure created by the movement of the piston from TDC to BDC. Second, the compression stroke, where the both valves are closed. Compression stroke is a compress into a clearance volume by the return stroke of the piston and ignite by the spark for combustion. For this reason, the pressure and the temperature is increased due to the combustion of fuel. Third, the expansion stroke. Same to the compression stroke where the both valves are closed. Expansion stroke is a high pressure of the burn gases force of the piston toward BDC and hence power is obtained at the crankshaft. And lastly, the exhaust stroke where the exhaust valve is open and the suction stroke is closed. Exhaust stroke is a burn gases expelled out due to the movement of the piston from BDC to TDC.
Before I will differentiate petrol engine from diesel engine, let's first understand their definitions. A petrol engine is a famous type of engine in which its air-fuel mixture ignites due to a spark provided by a spark plug, while a diesel engine is an engine that uses compression ignitions to turn energy of diesel fuel to rotary mechanical energy. In addition, both petrol and diesel engine is the internal combustion types of engines, meaning these engines burn air and fuel mixture inside the combustion chamber within the proper engine. The major differences between petrol and diesel engine are the following.
Petrol engine uses petrol as fuel, which is less expensive and easy to ignite, while diesel engine uses diesel as fuel, which is very expensive and difficult to ignite. In a petrol engine, ignition occurs due to a spark delivered by a spark plug, while in a diesel engine, ignition occurs due to a high compression of the fuel and air mixture. Diesel engine is more efficient compared to a petrol engine. Petrol engine operates on the Otto cycle, while diesel engine operates on the diesel cycle. Diesel engine has a high compression ratio compared to a petrol engine. Petrol engines have low maintenance and initial cost, while diesel engine has high maintenance and initial cost. A petrol engine has higher fuel consumption but produces less noise, while diesel engine has low fuel consumption but produces high noise while working. Petrol engines are most commonly depleted in small vehicles like vans and bikes, while diesel engines are depleted in heavy-duty automobiles like buses, tractors, and cars.
The different sources of farm power in various operation of agricultural are classified as human power, animal power, electrical power, mechanical power, and renewable energy. Human power is the main source for operating small implements and tools at the farm. Stationary work like shaft cutting, lifting, watering, threshing, winnowing, and it also done by manual labor. An average man can develop a maximum power of about 0.1 horsepower doing farm work. The advantage of human power is easily available and it used for all types of work such as plowing, soil leveling, constructing, bonds, drains, crop harvesting, and transporting, grain processing, and pest control. While the disadvantage is costliest power compared to all other form of power. Very low efficiency, required full maintenance when not in use, and also affected by weather condition and seasons. Animal power are still widely used as a major power source in many countries, like land preparation, wheat management, crop threshing, and transports are executed using animals' power. Oxen, bullocks, and buffalo are the most popular animals' power source of agricultural practices, although horses and donkeys, camels are used in many countries for transportation. Power development by an average pair of bullocks is about 1 horsepower for usual farm work. The average force a drain animals can exert is nearly 1/10 of its body weight. The advantage of animal power is easily available, used for all types of work, low initial investment, supplies manure to the field and fuels to the farmers, multi-purpose use for meat and milk, and also it is cheap to maintain, while the disadvantage is not very efficient. Season and weather affects the efficiency. It requires full maintenance when there is no farm work. Creates unhealthy and dirt atmosphere near to the residents. Very slow in doing work, and animals need feeding and protection against pests and disease. Broadly speaking, mechanical power includes stationary oil engines, tractors, power tillers, and self-propelled combines. The internal combustion engine is a good device for converting liquid into a useful work. There are two types of engines: the spark ignition engines or the petrol kerosene engine, and the compression ignition engines or the diesel engines. The advantage of mechanical power are the efficiency is high, not affected by weather, can run at a stretch, require less space and cheaper form of power. operate in harder condition than animals and humans. And also, it's operate in both wet and dry condition. While the disadvantage is initial capital investment is high, fuel is costly, and repair and maintenance need technical knowledge. The electrical power is used mostly in the form of electrical motors on the farms. Nowadays, the motor is a very useful machine for farmers. It is clean, quick, and smooth running. Its maintenance and operation need less attention and care. The operating costs remain almost constant throughout its life. Electrical power is used for water pumping, the dairy industry, cold storage, farm product processing, the fruit industry, and many similar things. Electrical power is very cheap form of power. High efficiency, can work at a stretch. Maintenance and operating cost is very low and not affected by weather. While the disadvantages is initial capital investment is high, it required good amount of technical knowledge, and it causes great danger if handled without care. The renewable energy is the energy mainly obtained from renewable sources of energy like sun, wind, and biomass. Biogas energy, wind energy, and solar energy are used in agriculture and domestic purposes with suitable devices. Renewable energy can be used for lighting, cooking, water heating, space heating, water distillation, food processing, water pumping, and electrical generation. This type of energy is inexhaustible in nature.
Indicated horsepower or IHP is the total output of power by a system, while brake horsepower or BHP is the amount of power by the engine. It is a theoretical approach for power measurement. The major differences between indicated horsepower and brake horsepower are the following.
Indicated horsepower is measured for determining the efficiency of the entire system, whereas the brake horsepower is measured for determining the efficiency of the engine only. Indicated horsepower doesn't include the power losses in the form of friction. On the other hand, the brake horsepower includes the frictional losses too. Brake horsepower is higher compared to indicated horsepower since it includes losses.
So next, I will discuss the working of 4-stroke cycle engine.
So this diagram gives a visual representation of how this process works. So for the intake stroke, the intake valve is open and the air-fuel mixture is drawn into the cylinder by suction as the piston goes downward. So this is the visual representation in the intake stroke. So for the compression stroke, both valves are now closed and the piston compresses the air-fuel mixture into a considerably smaller volume, making it ready for ignite. So this is the visual representation in the compression stroke. So for the power stroke, the spark plug located between the intake and exhaust valves will fire when both valves are closed, igniting the air-fuel mixture. The ensuing explosion pushes the piston down and turns the crankshaft, propelling the vehicle forward. This is the visual representation in the power stroke. For the exhaust stroke, as the piston rises, the exhaust valve opens, allowing the wasted exhaust fumes to exit the engine. The 4-stroke, 1-engine cycle have now been completed and the process will now be repeated. So this is an animated example for the working of a 4-stroke cycle engine.
So for the next topic, I will discuss the working of two-stroke cycle engine.
A two-stroke engine is a type of small internal combustion engine that uses two different piston strokes to complete one operating cycle. During the cycle, the crankshaft rotates once while the piston goes up and down once to fire the spark plug. So, the two-stroke cycle engine operates in the following manner. In the upstroke, the piston goes up. Air and fuel enter the crankcase. The fuel-air mixture is compressed and ignited. In the first stroke of the piston, the intake and compression processes are finished. This is the visual representation of the upstroke. For the downstroke, once the fuel is ignited, the piston is pushed down and the exhaust is expelled. In the second stroke of the piston, the power and exhaust processes are completed. This is a visual representation of the downstroke. So this is the animated representation of the working of the two-stroke cycle engine. A two-stroke cycle engine is a type of reciprocating engine that completes a power cycle with only two piston strokes. Following the completion of two piston strokes, a two-stroke engine completes one crankshaft revolution.
Let us discuss what is two-stroke engine.
Fuel for two-stroke engine has small amount of oil mixed into it. It is called two-stroke because just one up and down movement of the piston, the two strokes performs the full cycle of intake, compression, combustion, and exhaust. For the two-stroke engine, it goes through two stages or one complete revolution to complete one power stroke.
And now, you have learned what is two-stroke engine. Let us now discuss what is four-stroke engine.
A four-stroke engine, as its name suggests, has a piston that goes through four strokes or two crankshaft revolutions to complete one full cycle, intake, compression, power, and exhaust stroke.
The main difference between two and four-stroke engine is that four-stroke engine completes two revolutions to complete one power stroke. But of course, let us not forget to compare spark ignition and compression ignition.
Petrol engines are also known as spark ignition engines or SI engines works on the basis of Otto cycle or constant volume heat addition cycle. In SI engines, ignition process is carried out with the help of spark plug which ignites a mixture of air and fuel that is compressed in the combustion chamber. Whereas a diesel engine, or also known as compression ignition engine, works on the basis of diesel cycle or the constant pressure heat addition cycle. In CI engines, self-ignition occurs due to high temperature of highly compressed air. Hence, spark plugs are not required.